Hi folks, in today's video tutorial I'm going to show you how to create a spur gear based on the Involute. I got a request from you, so I'd like to show you step by step, but at the end we will generate the 3D model which looks like as this. What does it mean? Will be full parametric model. I would like to quickly show you. So what does it mean? We will create the feature which is called the curve from equation, and we will use some relations to generate this curve. Also, we will speak about how to generate the relations for the calculation of the tooth. So what does it mean? And full diameters of the wheel, or we can say the gear. So what does it mean? I have prepared the lot of relations which we will use. And then also we will use some techniques to generate the sketch plane or create the axis and so on. And what does it mean? I'd like to show you also that I have prepared for you on my web page 4ksite.com the block page. So if I will select the block, and over here you can see that is the Creo Parametric gear design step-by-step guide. So over here you will find full description, how to create model, how to specify relations, what does it mean, and how to create another feature step by step. And I would like to follow this step also in this tutorial. Yeah. So first of all, what I would like to do, I will copy all these relations. Yeah, you don't need to write it step by step. And over here are full calculation for the full gear. So simple to copy, and we can really jump to Creo and we can start from scratch. So we will create new, we can call it that is the gear 2, and we have a datum planes and coordinate system. Yeah, so this is most necessary thing what we need. And simple to say, we would like to start, as I mentioned, with the relation. So over here we have a possibility to select relation, or also you are able to select tools relations. I would like to really apply relation from the internet. Yeah, so from the web page. Simple, I will extend this and we can go here, and I'd like to explain to you step by step. In the example, for example, I'd like to create a first gear and will be module, for example, 1.5. The pressure angle will stay 20. Maybe, for example, we would like to create 21 number of teeth, and the profile shift value will be 0, and all others will be calculated. Also, we have some definition of the coefficient. And what I did, I always specified what the expression means. So for example, over here you can see the calculation and then also the explanation, what is it. So we will use the couple of dimensions for our sketches and features. So simple, I will use the final parameters, for example, D as the pitch diameter, or dA as the tip diameter or root diameter. Yes, so it's not so many, but all has been defined properly for the full calculation. So I finish, and now we would like to prepare first sketch. I will create a sketch. You can specify the sketch orientation and sketch plane. And over here we would like to really create a few circles. So I will start from inner circle, yeah, and we can simply create 4 of them because we really need 4 circles. I would like to explain to you what is it good, and we can say any dimension because we will specify dimension one by one based on the relation which has been calculated a minute ago. And as you can see here, for example, this is the root diameter, the another one is the diameter of the last involute, then we have a pitch diameter, and last but not least is the tip diameter. Yep, so what does it mean? Over here right now we will jump to the tools and relations, and we can arrange the windows and we can go step by step. On the internet you have an example how you can do it, so please read the article or follow this tutorial. So as mentioned before, this dimension is equal, and what I did, it's a df as the root diameter. Yes, so we will specify that the first dimension is the root diameter. The second value I would like to equal as the dimensions of the last involute point, so it's a DL. Another one, it will be equal to pitch diameter, and last but not least, it's the last one, and we will select, we specify the name as the DA. If we will confirm relations, everything is okay, so I wrote it properly, we can confirm OK, and the system will automatically change the dimensions based on the calculation from the relation. We can jump to sketch and we can simply confirm OK, and if you hit the Ctrl D, the system will orient the 3D model. Another thing what we would like to do, we would like to create and specify the curve, and which is defined as the involute. So if we will jump back to the web page, we can have a look here. The sketch is defined and we have specified the necessary dimensions. It depends the number here. When you create additional features, the system always create new numbering. So this is as the example. Yeah. So what we would like to do, we would like to create an insert model datum curve from equation. And what we would like to do, we would like to specify this calculation. And this is the involute equation defined in Creo. So what does it mean? I can simply copy this information and jump back to the Creo. And we will really create curve from equation. And simple, the system asks you, please specify the coordinate system. So we will specify coordinate system. And if you will select the edit functionality, you can simply paste the data. As you can see, the system will calculate the necessary information, and when you confirm OK and finish OK, the curve is created and it's based on the involute. I don't want to see the full length of the curve, so we can simply select the curve and use the trim functionality. And if we will use the tip diameter, so we can simply select the trim functionality, and we would like to trim by this curve, but I like the curve, select the full of them. So if you will only select, you can see that is only half curve. If you will hit the right mouse button, it will be full curve. So I like to see it, and where the arrow is located, this side will leave. So where is the arrow? So this one will be there, stay. So I will confirm OK, and this is the part what we would like to have. Okay, in future, we would like to make the rotation pattern around the axis. So maybe it will be good if I will prepare this axis before or up front. So simple, we can select two datum planes and specify axis, and system will automatically create axis between two planes. And we can hide the datum plane and axis. Now what we would like to do, we would like to create a new sketch, and the sketch will be defined as for the necessary tooth. So we can select the sketch and we can use the previous orientation, and the system will jump at the same orientation as before. If you would like to create a tooth on the left side, you can use the sketch setup and you can orient. So what does it mean? You can use the orientation of the sketch, so you can flip or you can set the position to the left, and everything will be as you need. So it's really about the specification of the orientation, and as you know, always during my tutorials I like to show you some more tips and tricks. So this is about the orientation of your custom sketch. You can also do it by right mouse button, and over there are the predefinition of the section orientation and so on. If you would like to know more, please check the previous tutorial about the sketch definitions. Now we would like to continue with the definition of the tooth. So what does it mean? We would like to project the existing curve. So simple, this is the first time when you are using it, you don't want to see it anymore, and the system wrote to you that you can hit the shift button or control button. I'd like to really use only this curve for now, so we will select and confirm, and the curve is selected. During the specification of the tooth, what you have to specify is the tooth thickness on the pitch diameter. So what does it mean? Over here we have to specify what is the thickness of the tooth. And how I can do it? I like to do it with a simple way, and we would like to also project this existing curve, but as before, I don't want to select only part of this curve, but I like to use the full one, so I will select right mouse button and left for confirmation, and then I will confirm create geometry and close tab. Now the full curve is projected, and I will use the definition of the trimming. So what does it mean? I would like to divide the existing curve, and I will divide this curve, for example, here. So what does it mean? When I will use the delete segment, the system allows to me to specify until which point I like to delete, and then I like to delete what is everything around, and my part of the curve exists here. And for what is it good? We would like to create the dimension which is definite as the length of the arc, because the calculation of the two thickness on the pitch diameter is called S. I will jump back to the over here, and what we can see here, it's a S calculation, it's a two thickness at the pitch diameter. Yeah, so, and I like to use this function and calculation. If you would like to create the dimension for the arc and definition of the length of the arc, you have to select dimension, you have to select the arc, endpoint, and middle button. Yeah, so simple, you will create the necessary dimension, and now we will jump back to the tools relations, and we will specify the length of this one is the definition of the two thickness divided by 2, because I like to only have the half of this trajectory length. So we will create and confirm OK. What does it mean? We have a half of the tooth definite, and now we will use the sketch, and in the sketch we will create new center line which will go through the end of the arc, and we will finish. So everything is fine, and this curve I like to really create and use only as the construction, so we will select this curve and use the constructions. Now we are able to select the existing projected spline. We can call it spline, it's a trajectory of the involute, and we would like to use function mirror around new center line. So what does it mean? We have specified the necessary shape and the thickness of the tooth definite on the pitch diameter is set based on the relations again. What we would like to do, you are able to project the top line, yeah, or you can simplify the shape and you can only use the straight line here. And also over here on the bottom, you are able to create your custom shape. For example, you will use the straight line, or you will create a round here around directly. So you are able to create an arc and play with dimension. I would like to simplify it in this video tutorial, and also in my model is also good. So I will really create only simple straight lines. So the full first tooth is created, definite on the shape, and I will finish the extensions. So what does it mean? If I will finish, we have a sketch definite. Now we would like to maybe continue, and I can say that we have almost everything ready. So what we would like to do, we would like to create a body of the gear. So what does it mean? We will use the sketch region. We can see that system would like to really select only part. So what does it mean? Maybe it will be better if I will create the extrude feature before. So I will drag in the model tree, and we do not see the latest sketch. We can use the sketch region, and I like to really extrude this feature. And when we will extrude, we can use the symmetric, and for example, thickness will be 10. Yeah, it's about the specification, what you would like to use, confirm OK, and now we can drag and the sketch will be created. So what does it mean? Now we would like to select this sketch, and we would like to extrude the latest sketch. And again, maybe we would like to specify the thickness, but also you are able to specify that you would like to have the reference on the left side, and also maybe you would like to specify reference on the right side. and the first solid tooth is created. When we will finish OK, then we are able to hide maybe all unnecessary curves. So this curve is not necessary, so I can simply hide and will be perfect. So our geometry is ready and all dimensions are set. I'd like to continue. So what does it mean? We would like to specify some parameters. First extrude feature, if I will select edit, we have a dimension 10, and if I will select it, the system will show me the dimensions and the name of the dimension is D10. Maybe we would like to specify that it's a thickness. So for example, you can specify the parameter B. And what does it mean? If this parameter is set, we can reuse in relation and specify it. So I like to jump to the parameter B. And for example, here we would like to specify the parameter, local parameter, and I will use only default visibility, will be not so many parameters, and we will really create new and will be, for example, width. Yeah. So what does it mean? I'd like to drive the width by parameter and we will change dimension B. So simple to say, for example, width will be 15, and over here in the relation on the bottom we can write that you can make a comment. Yeah, over there will be width definition, and below you can write that parameter B is driven by width. And simple, you can use the right mouse button, insert to relation, and system will write the relation here. If you would like to have a same comment at the end of the expression, you can simple use the copy and paste, and over here you can leave some space and will be arranged of the node. Yeah, so perfect. The width is specified. So what does it mean? Now the width is driven by parameter 15. In reality, at the beginning was 10. What does it mean? If we will regenerate, now we can see that it will be 15. Yeah, so simple to say, it was really easy to update it. In the similar way, we would like to continue with the pattern feature. So what does it mean? We will use the pattern of the extrude feature. We can use and select the extrude feature. You can use the pattern from the ribbon. And we would like to use the pattern around axis. So it was reason that I created axis here, and we would like to count automatically number. So what does it mean? From 4 you will change to 5. What does it mean? The 5 tooth will be created. But we don't want to change the number of pattern manually. We would like to do it also by number of the tooth. So what does it mean? We can simply select. If we would like to change the parameter name of the P19, and for example over here you can write that is the number of teeth. Yeah, so what does it mean? And if I will finish, I can use this functionality. So what does it mean? Directly in the expression of the relations, you are able to set the new expression, and we can simply select the pattern feature. Now you can see that over there is the dimension name, we can say, and then we can say that it will be equal number of the tooth. So simple to say, over there is the number of teeth, and it's a 21. So it will be, the pattern members will be 21, simple to say. So when I will come from OK and regenerate, Ctrl G, now we can say that we have a 21 teeth. And now it's about the changing and validation if everything works well as before. So what we would like to do, we would like to simply change some information input. So it is reason that at the beginning I have had this one. So for example, you can change, for example, module 2. You can come from, let's see, if I will regenerate, perfect, dimensions are different. Maybe it will be better to see number of teeth. So for example, we can specify that we would like to have 45 tooth altogether. And if I go Ctrl G, it will be much bigger. It's great. So now it's really only about how you would like to put the input. If you would like to put the input directly from here, means that from relation you change the parameter value downstairs, Or, for example, I will delete these 2 or 3 inputs. Yeah, I will simply delete. What does it mean? If I will check, I can change the parameter directly because it's not now driven by relation, but we would like to change parameter step by step manually. So I can select parameter here. And for example, from module 2, you can put number 3, and downstairs it's for example number of food will be, for example, 35, doesn't matter. Yeah, so simple. If I will regenerate, the number is changed. So it is one way how you can change it, and now you can really play only with the values. If you would like to change the width, you can change it at the bottom. Again, from 15 you can change it to 26, okay, and regenerate. Yeah, so it works well. And last but not least, what we would like to apply is the round feature. So what is great that you can select the round feature, and if you would like to make a round feature on the intent edges, so you can move mouse and use the intent edges for the extrude feature. So select the right mouse button, system will select and choose for you intent edges. You can specify the value. Yes, of course, you can possible to calculate what is the difference between the root diameter and the last involute point and so on. But for now, for the quick example, I will use the number 1.2. And if we will use the pattern feature and finish, the system will automatically calculate and create the round around. At the end, apply the hole and additional extrude feature or revolve feature, and your spur gear will be finished. So in this video tutorial, I have shown you how you can create a spur gear with the involute teeth, and also how to make the parameterization, how to use the parameter relation, and how to work with the feature and some custom preferences. I'd like to thank you for your questions. Stay tuned, and bye-bye. Vladimir.